Welcome, my name is Dr. DrWedding, and this is DrWedding DC21. Mesh analysis with voltage and current sources. In this video, you will learn how to solve series parallel circuits that have more than one power source in them. These sources may be voltage sources, current sources, or both. Mesh analysis is based on Kirchhoff's voltage law, and if you do not understand KVL, you will not understand mesh analysis. If you are unfamiliar with KVL, you may want to go back and watch DrWedding DC10. As a quick review, Kirchhoff's voltage law states that the sum of the voltages around a closed path is zero. The equation is shown below. Kirchhoff's voltage law will be demonstrated using this circuit that has already been solved. In simple terms, KVL states that if you start at any point on a circuit, you can move along any path and add up the voltages you encounter. When you enter on the positive side of the resistor, you will add the voltage. And when you enter on the negative side of the resistor, you will subtract the voltage. And as long as you come back to the starting point, the voltages will add to zero. For example, start at the star in the lower left of the circuit and move counterclockwise following the path shown here. The first voltage you encounter is -4 volts across R2. This is negative because you entered on the negative side of the resistor. Next, you will encounter a -2 volts across R1. Lastly, you will enter the 6-volt supply on the positive side, so you will add +6 volts. When -4, -2, and +6 are added together, the answer is 0. It is crucial to understand that you add values when the path enters on the positive side of a resistor or supply, and you subtract values when you enter on the negative side. If the starting point was the star on the upper left of the circuit, and you followed the clockwise path shown here, the previous equation would become +2 volts plus +4 volts minus 6 volts, and as before, this would add to 0. It is also important to understand that the path does not matter. In this example, the starting point is the star on the upper left of the circuit, and the path is a figure 8. And as you add and subtract the voltages, the result will always be 0. Mesh analysis is based on KVL. You will add up the voltages across each of the resistors in a closed path and set them equal to 0. However, the voltages are unknown. To fix this problem, you will create temporary currents and multiply them by the resistors. This will create temporary voltages. Using the temporary voltages, you can write the KVL equations in terms of the currents. Once the KVL equations are generated, they can be solved simultaneously to find all of the currents. Once you know the currents and resistances, you also know the voltages. This may sound confusing, but it is very easy, and it will become clear when you see an example. Mesh analysis will be demonstrated using the circuit below. As always, you start with creating a table. Then you can follow 5 easy steps to solve this circuit. Step 1. In each window, pick a current direction and give it a name. Do not worry about the direction of the current. You can't pick the wrong direction. It will always work. A window is a term I use to represent the blocks that make up the circuit. In almost every example, on every website, in every video, and in every textbook, the current direction is shown using a half circle. After decades in the classroom, it is my opinion that this is not the way this should be taught. Instead, use a square made up of 4 arrows. You may be wondering what is the difference between the circles and the squares. I have found that students who use half circles in mesh analysis will often miss overlapping currents. In this example, the circles give the false impression that only I1 is flowing in R2. And because the circle is open on one side, I2 is often left out of the equation. The half circles also look identical. This often gives the student the false idea that the two currents in R2 are in the same direction. For these reasons, I teach the students to use the squares. When the squares that are made out of arrows are used, the students can clearly see there are two currents in R2, and it is also clear that they are flowing in opposite directions. I would strongly recommend drawing your current directions like this. Step 2. On all of the resistors, add a plus sign on the side where the current enters and a minus sign on the side where the current exits. If there are two currents in a resistor, such as R2, the resistor will have two plus signs and two minus signs. Step 3. Go around each window and generate a KVL equation. In this example, you will generate two equations. Because the voltages are unknown, you need to multiply the resistor times the temporary current to generate temporary voltages. To generate the KVL equations, you can start anywhere and go in any direction. But to make it easier to learn, I will always start at the bottom left of the circuit and move clockwise. So I will start at the green star. When going up the left side, you encounter a minus sign first, so the equation starts with a negative sign. KVL is made up of voltages, and this is a 6-volt power supply. So in the KVL equation, this is a constant. Therefore, the equation starts with -6. When going across the top of the circuit, you encounter a plus sign, so the next voltage is added to the KVL equation. We don't know the voltage across R1, but we can get a temporary voltage by multiplying the 200 ohm resistor and the current I1. So the next value in the KVL equation is plus 200 I1. When coming down the right side of the window, you will encounter a green plus and an orange minus sign. This means that there are two currents flowing through R2. Because there are two currents, there will be two voltages added to the KVL equation. The first voltage is added because you encounter the green plus sign when going from top to bottom. This first voltage is equal to the 800 ohm resistor multiplied by the green I1 current. The second voltage is subtracted because you encounter the orange minus sign when going from top to bottom. This second voltage is equal to the 800 ohm resistor multiplied by the orange I2 current. When you go across the bottom of the window, there are no resistors, so you do not add anything to the KVL equation. Now that you have returned to the starting point, you set the equation equal to 0. By combining like terms and moving the constant to the other side of the equal sign, the first KVL equation is generated. To generate the second KVL equation, I will start at the lower left side of the second window. This location is marked with an orange star. I will go around the path clockwise. When going up the left side of the second window, you will encounter a green negative sign and an orange plus sign. This means you will generate two voltages in the KVL equation. On the right side of the resistor, you will encounter an orange plus sign. This means you will add the voltage generated by multiplying the 800 ohm resistor and the orange current I2. On the left side of the resistor, you will also encounter a green negative sign. This means you will subtract the voltage generated by multiplying the 800 ohm resistor and the green current I1. The top of the right window does not have a resistor, so nothing is added to the KVL equation. When you come down the right side of the window, you will encounter an orange plus sign. So you will add the voltage created by multiplying the second 800 ohm resistor times I2. There are no resistors on the bottom of the second window, so nothing is added to the KVL equation. Now that you are back to the starting point, you set the equation equal to 0. By combining like terms, the second equation is generated. Step 4. Solve the two simultaneous equations to find I1 and I2. You can solve these equations through substitution or by converting the equations into matrices. I will use the free online calculator shown in the link. The online calculator uses single letters as variables, so I will use X for I1 and Y for I2. The two equations are typed in and separated by a comma. When the Go button is pressed, the solution for I1 and I2 are given. Step 5. Fill in the table. The green current I1 is equal to the total current exiting the power supply and the current through R1. The orange current I2 is the current through R3. Resistor R2 has both currents flowing through it. So, the total current in R2 is the combination of both of these currents. These currents are in opposite directions, so the magnitude of the current through R2 is the larger current minus the smaller current. If these currents were in the same direction, the two currents would have been added together. The direction of this combined current is the same direction as the larger current. In this example, it's in the same direction as the green I1 current. Once you have all the currents and all the resistances, you can calculate the voltages using Ohm's law. This is the final answer for this circuit. In this example, both current values were positive. That means the current directions you picked were correct. If any of the calculated currents were negative, you would simply reverse the arrows on your circuit and make the current positive. Assume you had chosen the current directions shown below. In this circuit, the orange current I2 is reversed from the previous example. This causes all of the orange plus signs and orange minus signs to switch positions. This would generate two different KVL equations for this circuit. When these two equations are solved, you end up with the green I1 current as a positive value and the orange I2 current as a negative value. To fix this problem, reverse the orange arrows and make I2 positive. Then fill in the chart as before. As you can see, you will end up with the same answers as before. As I stated at the beginning, you can't pick the wrong direction for the current. It will always work out. Here is example 1. It is a bit larger. Because it has 3 windows, it will have 3 equations and 3 unknown currents. Solve this circuit using mesh analysis. As always, start with a table. Step 1. In each window, pick a current direction and give it a name. Step 2. On all of the resistors, add a plus sign on the side where the current enters and a minus sign on the side where the current exits. Step 3. Go around each window and generate a KVL equation. In this example, you will generate 3 equations. To get the first equation, start at the green star in the lower left of the first window and go around it clockwise. The first equation is minus 10 plus 30I1 plus 40I1 minus 40I2 plus 30I1 equals 0. Then combine the like terms. To get the second equation, start at the orange star and go clockwise around the window. The second equation is minus 40I1 plus 40I2 plus 10I2 plus 60I2 minus 60I3 equals 0. Then, simplify the second equation by combining like terms. The third equation starts at the purple star in the lower left of the third window. The third equation is minus 60I2 plus 60I3 plus 10I3 plus 20I3 equals 0. Then simplify by combining like terms. Step 4. Solve the 3 simultaneous equations to find I1, I2, and I3. The equations were solved in this example using the same online calculator as before. Step 5. Fill in the table. I1 is equal to 129.6 milliamps, and it is the total current and the current through R1 and R3. I2 is equal to 74 milliamps, and it is the current through R4. I3 is equal to 49.9 milliamps, and it is the current through R6 and R7. I1 and I2 are combined to get the current through R2, and I2 and I3 are combined to get the current through R5. The missing values on the chart can be found using Ohm's law. The complete solution is shown here. Here is example 2. In this example, the circuit has two voltage supplies. As always, start by creating a table. Step 1. In each window, pick a current direction and give it a name. Step 2. On all of the resistors, add a plus sign on the side where the current enters and a minus sign on the side where the current exits. Step 3. Go around each window and generate a KVL equation. This is done the same way as it was done in the previous examples. When you reach the voltage supply in the second window, you treat it the same way as the voltage source in the first window. It is just a constant that is added or subtracted from the equation. After the equations are generated, they are simplified by combining like terms. Step 4. Solve the two simultaneous equations to find I1 and I2. I solved these equations using the online calculator. The negative sign on I2 means the assumed current direction is backwards. But this is a very easy fix. Just reverse the I2 current arrows on the circuit and drop the negative sign on I2. Keep in mind, now that the current has reversed direction, so have the plus and minus signs across the resistors. This is the circuit that you use in Step 5. Step 5. Fill in the table. I1 is the total current from the 9-volt supply and the current through R1 and R3. I2 is the total current from the 6-volt supply and the current through R4. I1 and I2 are going through R2 in the same direction, so the two currents are added together. Finally, Ohm's law will give you all the remaining values. This is the complete solution for this circuit. Example 3 has a voltage source and a current source in it, and this may be the easiest type of mesh circuit to solve. Solve this circuit using mesh analysis. Start by generating a table for the values. Step 1. In each window, pick a current direction and give it a name. Part of the reason this type of question is so easy is because you already know the direction of I2. The arrow in the supply is the direction of current flow. Step 2. On all of the resistors, add a plus sign on the side where the current enters and a minus sign on the side where the current exits. Step 3. Go around each window and generate a KVL equation. This is where this problem really gets easy. You already know I2. It is the current supply value. In this example, I2 is 15 milliamps. Because you already know the current I2, you do not need to create temporary voltages. You can get the exact voltages from Ohm's law. The resistor R4 has 15 milliamps through it, so the total voltage across it is 3.75 volts. The resistor R2 has two voltages across it, one generated by I1 and one generated by I2. The sum of these two voltages is the total voltage across R2. Because you know I2 is 15 milliamps, you know the voltage due to I2 is 2.7 volts. You only have one unknown current, so you only need one equation. So if you start in the lower left of the first window and go around the circuit clockwise, the KVL equation will be minus 10 plus 125 I1 plus 180 I1 plus 2.7 plus 100 I1 equals 0. You can easily find I1 using simple algebra. I1 is 18 milliamps. Step 5. Fill in the table. I1 is the total current exiting the 10-volt supply, the current through R1, and the current through R3. I2 is the current exiting the current supply, and the current through R4. I1 and I2 are going through R2, and in the same direction. So, the current through R2 is the sum of these two currents. Ohm's law will get a lot of the values on the chart, but one value, the current supply, does not have enough information to fill in the missing values. But KVL will come to the rescue again. If you start at the star and go clockwise around the highlighted path, the voltages will add to zero. The only way this can be true is if the voltage across the current supply is 9.7 volts. If you start at the star and go clockwise around this new highlighted path, the voltages will sum to zero. The only way this can be true is if the voltage across the current supply is 9.7 volts. This second KVL path was done to show you that the path does not matter. You will always get the correct values. This second value will allow you to calculate the equivalent resistance that is across the 15 milliamp supply. And now that the table is filled in, along with the circuit showing you the directions of the current, you have the final answer. I hope this video has helped you understand mesh analysis and how to use it to solve series parallel circuits that have multiple voltage and current supplies. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.